Alright guys, today we're going to talk about trig identities. So, what is an identity? Well, it's just a way we can manipulate one of our trig functions here, and it's always going to be true. Like, we know that sine is 1 over cosecant. Cosecant is 1 over sine. You already know these guys. Which we did discuss before, but I don't know if you remember. Tangent is the quotient of sine and cosine. So sine divided by cosine will always equal the tangent value. We talked about that in geometry also a little bit earlier this year. So all of these you should already be familiar with. So again, these are identities. They're always true. Okay. The last fundamental trig identity we're going to talk about is the Pythagorean identities. And as you might guess, it comes straight from the Pythagorean theorem. But we're not going to go how it was derived. We're just going to go with using the identity. The main one, cosine squared plus sine squared equals 1. If you remember all of these, that's the identities that the ACT will expect you to have memorized. For this class, I'll let you use a reference sheet. In fact, this is it right here. On the front will be the unit circle, which I'll show you how to use in a little bit. And on the back will be your identities. We're going to get to these identities later. Right now, we're focusing on these guys. Alright, so let's just get down to it. It says, find the exact value of sine of theta if cosine of theta is negative 4 over 7. And look at this condition here. It's giving us a range for theta. Now, you might be like, why is there pi's in here? Well, one handy reason I gave you the unit circle is because it does have the conversion between radians and degrees on here. So this is called the unit circle because its radius is 1. 1 what? 1 radian, actually. And if we find the circumference of the circle, we know there's 360 degrees in a circle all around, but there's also 2 pi times the radius for circumference, so 2 pi times 1 is 2 pi radians in the unit circle. So if we go from the starting point here all the way around, that's 2 pi radians. Okay, this says from pi over 2 to pi. So all you have to do is look, where's pi over 2? It's right here. Pi right here. So we're looking in this second quadrant here. Okay. The main thing this tells you is the signs. That's all you're looking at is what sign is it. Is it going to be positive? Is it going to be negative? And if we're looking at sine in the second quadrant, this is cosine theta, sine theta. In the second quadrant, sine being your y value is going to be positive. Okay. So cosine your x's, sine is your y's. So quadrants 1 and 2, our sine values are positive. Quadrants 1 and 4, our cosine values are positive. And if we divide those, 1 and 3, our tangents are positive. Okay, negative over negative is positive. Anyway, so this part right here just tells you what sign we're going to be dealing with. So first thing you're going to do is draw a triangle. In fact, you're going to draw a right triangle, or something like it. Now, you could draw it in the proper quadrant, or you can just draw it. If we were drawing the proper quadrant, quadrant 2, our triangle would need to look like this sort of thing. Actually, let me get the unit circle on here. Just so we can see how it works. Give it a moment. There we go. So if we're looking at the unit circle, this is our vertex, and we're always going to look at the horizontal. So this line is always going to be part of our triangle. And we're always going to come out like this. So this, let me do a better job. This angle right here is our theta, which is 45 degrees. So the result for 45 degrees, sine is the y value, so square root of 2 over 2. Cosine is also square root of 2 over 2. Over here, if we look the other side, if we're looking at, let's say, cosine of 150 degrees, again, this is our theta, 150 degrees would actually, 150 degrees would be this angle right here, but if we look at it, cosine is negative square root of 3 over 2. Okay, so when we're drawing these things, if we look at the quadrant, it should be coming from that center point and then going to our x-axis. So that's our different triangles we could draw. Or again, you can just completely ignore that and just figure out what sign you need, because that's all you need to know from that anyway. Alright, so here's my triangle. That's a quadrant 2 triangle. So that's my theta. Cosine of theta is negative 4 over 7. Cosine is adjacent over hypotenuse. Same basic trig applies here. So again, we're going to use the Pythagorean theorem. We got, let's call that x. X squared plus negative 4 squared equals 7 squared. Alright, so figure that out. 49 minus 16, that's 33. So x is square root of 33. Now here we do need to take into consideration the negative. It could be negative. In this case, it's not. We're in quadrant 2, it's positive. So that's just going to be square root of 33. Alright, and if we think sine is opposite over hypotenuse, so sine of theta is going to equal square root of 33 over 7. Now, let's look at this one. This one gives us our quadrant in degrees, so between 180 and 270. 180, 270. There we go. That's the third quadrant. So we know sine and cosine are going to be negative, tangent's positive. So if we want to draw our triangle properly, it would look something like this. And here's where we're always going to put our theta at this vertex angle here. This is always going to be our 90, wherever it's coming from the horizontal. And if we do that, cotangent, well, cotangent is reciprocal of tangent. Tangent's opposite over adjacent, so this is adjacent over opposite. And if you don't remember, Sokotoa, some old hippie, caught another hippie tripping on acid. And for the reciprocal identities, you just flip those. So for the reciprocal of sine, that's cosecant, it's going to be hypotenuse over opposite. For secant, it's going to be hypotenuse over adjacent. For cotangent, it's adjacent over opposite. Adjacent to opposite 5. And these are both going to be negative because we're in the third quadrant. Okay. So negative 2 squared plus negative 5 squared equals x squared, whatever the heck you want to call it. 4 plus 25 is x squared, so square root of 29. Now, one thing to note, your hypotenuse is always positive. Okay? If we look at the unit circle, again, we're basing all this on this circle right here. The hypotenuse in all those triangles was our radius, and the radius is always positive, so it's going to be positive. Okay? Hypotenuse positive. What did I want? Cosine, adjacent over hypotenuse, negative 2 over square root of 29. Rationalize that denominator. You can just type that in. Negative 2 square roots of 29 over 29. Yes, you need to rationalize, simplify, but all you have to do is take it and type it in. That's a fancy schmancy calculator I made you get. Same thing there. Let's do it. Last one of that kind. Cosecant. What's cosecant again? Let's look. Cosecant is the reciprocal of sine. So if you think back, sine is opposite over hypotenuse. Cosecant is going to be hypotenuse over opposite. So it's negative 2. Well, let's stick a number on the bottom of that. How about a 1? Which quadrant are we in? We're in the fourth quadrant. Square root of 3 over 2 and 2 pi. It doesn't have 2 pi right here, but it is a full circle, so it is 2 pi units. So hypotenuse over opposite, but again, the hypotenuse cannot be negative. So if you were to think about it, this is going to be our triangle. Hypotenuse over opposite. That right there is the negative. And you might recognize that. 1, 2 square root of 3, right? That's a 30, 60, 90 right triangle. And again, these nice numbers here are based on our 30, 60, 90 triangle. So if you know those, you already know the unit circle. We'll deal with that later. For now, let's just figure this out. Tangent. Again, there's my theta. Opposite over adjacent. So it's -1 over square root of 3. Negative square root of 3 over 3. Okay. So that's just applying those identities and using some basic right triangle trig. You should know all that already. We had a test on that a few weeks ago. We just didn't consider signs. Everything was positive for us. We were just looking in the first quadrant. Now we expanded it to be any of these quadrants, and we just have to read which quadrant are we in. So if it helps you out, you could say this is quadrant 4. So you know what's positive and negative. You're like, oh, that's quadrant 3. And this one's quadrant 2. That's all that this part is telling us. Don't let it confuse you. Now, let's get down to actually manipulating these trig identities. We're getting into proofs, okay? Proofs for trig are less fun. Let's just go with that. They're not fun. But they're not hard either. You got a basic process to do, and the trick is get everything in terms of sine and cosine. Is that 100%? No, there's nothing 100% in proofs, but it's a good general starting point. So if we look at secant, secant of theta is 1 over cosine. So I'm going to rewrite this, and yes, you must write step by step. And the thetas are important. And I'm just going to go to the next line. That's sine of theta times 1. Well, that's just sine of theta over cosine of theta. And hey, we know what that is. That's tangent of theta. Let me do it down here. And if you don't know what that is, sine of theta over cosine of theta is tangent of theta. It's right there on your identity sheet. Again, I'm going to let you use it. College, you won't be so lucky. Let's check this one out. We got a tangent times a cosine. What do? Write everything in terms of sine and cosine. Our goal here is to simplify, basically, to get it to one number or one trig function. Excuse me. So yeah, we're going to get this into one trig function. Tangent we just saw was sine of theta over cosine of theta times cosine of theta. And yeah, those cancel out. So we just are left with sine of theta. And let's move right along. Okay, now we got something more interesting. Secant squared theta minus tangent squared theta. Well, here's a hint. Anytime you see squared, let's look at our Pythagorean identities. Here we go. Here's the one relating tangent and secant. So I'm going to use that before I turn everything into sine and cosine and see what happens. So I know secant squared theta is equal to tangent squared theta plus 1. Well, let's put that in there. So instead of secant squared theta, I'm going to write tangent squared theta plus 1. So 2, and this right here is tangent squared theta plus 1 from this identity right here. That's what we're using. We're just replacing it. Minus tangent squared theta. And you should see what happens. We're left with 2 times a 1, which is indeed a 2. Sine squared minus cosine, oh wait, no, it's cosine squared minus sine squared. That's not 1. Cosine squared plus sine squared is 1. Let's figure out what this is. Let's see, cosine squared minus sine squared. So here's what I'm going to do. I'm not sure which way I'm going to go, so I'm going to take this identity and manipulate it. So I'm going to write it down, and then I'm going to rearrange it. I could solve for cosine, I could solve for sine. I'm going to do both ways for this particular example, but both will be correct. So I'm going to do this in 2 different ways with 2 different results, and both results are correct, okay? So whenever we do identities, you're going to already have what we are trying to get it to equal. So that'll tell you where to go. Here, we're just simplifying it. So sometimes there's more than one simplest answer. So I could rewrite this as cosine squared theta equals 1 minus sine squared theta. Or I could say, instead of subtracting sine, I could subtract cosine. I could say sine squared theta equals 1 minus cosine squared theta. We can do it either way. So I'll start with replacing the cosine. So I'm going to say cosine squared theta is equal to 1 minus sine squared theta. So I'm just going to rewrite that. 1 minus sine squared theta minus sine squared theta. Okay, well that's 1 minus 2 sine squared theta. If you have negative x minus x, it's negative 2x. Same thing, guys, same thing. Let's try it the other way around. What happens if I replace sine squared theta with 1 minus cosine squared theta? Okay, this is being subtracted, so let's make sure we consider that in parentheses. This is the same problem using this part of the identity. So it's not a new problem. It's not part of this identity. It's completely restarting. Cosine squared theta minus 1 minus cosine squared theta. I think you can do the distributive property. That's going to be a negative 1. That's going to be a positive cosine. That's going to be 2 cosine, because it's cosine squared, plus cosine squared minus 1. Okay, so both of these results are perfectly good. Either way you do it, fine. But again, later, well, soon, our goal is just going to be to prove what it wants us to prove. So it's already going to give us what it wants us. It's going to tell us make it look like this, or it's going to tell us make it look like that, or it might do something completely different. It might turn this into some tangents or something. Who knows? But right now, our job is just to try and manipulate these identities right here in order to make it look different and more simplified. We don't want 2 trig functions. We don't want sine and cosine. We don't want that. We want either sines or cosines. Okay? So we just want numbers like this one. Turned out to be just a number, or we want 1 trig function. Let's look at this thing. This thing's got some multiplication and some division. But again, we're dividing by tangent, okay? First thing you're going to want to do is turn tangent into sine and cosine. Unless you're dealing with the Pythagorean identity, start there. But if nothing's being squared, turn everything into sine and cosine. Leave the top alone. And I'm going to rewrite that. Divided by, if you don't remember, it's sine over cosine. Now this looks terribly complicated, doesn't it? Well, guess what? It's not. You just have to remember, How do you divide by a fraction? You flip it and multiply. So instead of dividing by this, I'm going to multiply by its reciprocal. So the top part, not changing. Bottom part, we're going to reciprocate it and multiply. And hey, would you look at that? The cosine times cosine is cosine squared. Sines canceled. We're left with cosine squared theta. That's it. Okay, we got a square in here. We got a square. So here's what I'm going to do. I already wrote this. Sine squared theta equals 1 minus cosine squared, so I'm going to use that. No harm in recycling. So whenever we get down to it, it's going to be handy if you write down on the side which identity you're using and manipulate it so you can make it look like how you need it. Because right here, cosine squared plus sine squared equals 1 doesn't exactly help you in this case. Here, though, now we know what sine squared looks like. We can just substitute it in. And we're going to distribute that -2, so let's see what happens. And all of that is over cosine of theta. Make sure you pay attention to multiplication versus addition. So right here, this is being multiplied. Right here, these are being added and subtracted. So 2 minus 2 is nothing. But you can't say -2 plus 2 or anything like that. That's not going to work. No. This is being added to cosine squared thetas. They're not like terms. Don't try and make them like terms. But that will simplify to 2 cosine squared theta on top. Cosine theta on the bottom. And think for a second, what's x squared over x? When we're dividing, we subtract the exponents. That's an understood 1, so that's just x. So cosine squared divided by cosine is just cosine. So that's 2 cosine theta. So our basic outer rules still apply here. Couple more. All right, yeah. So this one's looking a bit tricky. Again, I see a square. I'm going to start with the Pythagorean identity. Maybe. Let's see, what's secant? Secant, that's just a cosine. So yeah, since I'm dealing with secant, that's cosines. That's a sine. Probably going to need to make this look like a cosine or something. I have no idea. We're just going to go with it. So this time I'm going to use this blue one here. Okay, let's try that. Let's see what happens with this. I don't have the slightest idea. So I'm going to go ahead and rewrite these as cosine because I know I'm going to need to. 1 over cosine of theta times. Now why did I do that? Grab the wrong one. We need this one again. Sorry. Times, parentheses, 1 minus cosine squared theta. Okay. Over big freaking division bar here. 1 plus 1 over cosine theta. Now here's where algebra comes into play. Some old algebra that you probably haven't needed to use in a while. Fractions. How do you mess with fractions, y'all? Gotta have a common denominator. This has a denominator 1. You can't divide a fraction by a binomial. You gotta make it one thing. So we're gonna have to make this a single denominator on the bottom. Right now we have two separate beasts. We have the numerator beast, the denominator beast. Numerator, not so bad, we're going to distribute. Let's do that now. So this whole thing is going to be over cosine theta. Easy enough. No, these do not cancel. We have a binomial on the top. Now the bottom's where it's going to get tricky. Okay? We're going to need to rewrite this 1 right here with the same denominator as this thing, which is the cosine of theta. I know my denominator needs to be cosine of theta, so what does my numerator need to be? Well, to get from 1 to cosine of theta, I multiply by cosine of theta. Do the same thing on the numerator. Oh yeah, anything divided by itself is indeed 1, so we're good. Now, technically we'd say plus 1 over cos. I'll go ahead and do it. But I will let you skip to the next step without writing this step if you want to. So we need to combine these. So all we really have to do, once we get our common denominator, is put it as a common denominator. So right now this thing is looking nasty. Let's see. We got some work. Big freaking division bar, y'all. How do we divide by a fraction? Flip it and multiply. 1 minus cosine squared theta over cosine theta, not messing with the numerator, times the reciprocal of this thing, cosine theta over, and I'm going to rearrange this. Instead of cosine theta plus 1, I'm going to do 1 plus cosine theta. You don't have to, but this guy's got a 1 first. This guy, let's put that at 1 first. Maybe we'll need it, maybe we won't. Those cosines are lucky enough to cancel out. So now we're left with this thing, 1 minus cosine squared theta over 1 plus cosine of theta. Somebody said it. No, I don't think anybody at all said it. But what do you recognize this as? What is it? What is it? It's a difference of squares. Let's factor that thing. 1 minus cosine theta times 1 plus cosine of theta. And would you look at that? 1 plus cosine theta down here. That's going to cancel with this one. And we're left with 1 minus cosine of theta. That was a bit long. These can get rather long. They can. They will. They will. Whenever we get to proofs, it's going to have some long ones. But that's okay. Just go step by step. Do the arithmetic, do the algebra, turn everything inside the cosines, repeat. Okay? I think the hardest part about this is your lack of fraction skills. Okay? That's what's going to get you most of the time. So just take your time with the fractions. Last one. So I see sine here, I see sine there, I see cosine there. They're all squared, so why don't we just use the Pythagorean identity and turn one into the other. Now I could replace both of these with cosines. Probably not. I mean, it's probably going to be easier if I just turn the other way around and replace the one cosine with some sines. What's going to happen? I have no idea. Let's find out. Hey, come back. So let's do this and see what happens. So again, if we got squareds, yeah, squares, I guess. Probably want to take a look at the Pythagorean identities first and see how they could play out. But like here, we had a sine and then a secant. It just wasn't happening. So Pythagorean identities were not even used here, even though we had a square. So it's a good idea to look for it, but not necessarily use it. It's a puzzle, guys. You just got to figure it out. All right. So not messing with sines, messing with cosines. Put some big freaking parentheses around this thing. And that's times sine squared theta. Is this going to help us out? I don't know. Let's find out. Let's distribute that. Okay, here's what I'm going to do. We got this negative sign and we got this sine squared. So I'm going to think about that as negative sine squared to make that positive. That's what I'm going to distribute, okay? Okay. So let's not mess with this guy. Sine squared theta. And then that's going to be, again, that's plus now. So negative times 1, that's a negative sine squared theta. And this is going to be a positive x squared times x squared is x to the fourth. So same thing here. Sine squared times sine squared is sine squared to the fourth. So sine squared to the fourth. Sine to the fourth, sorry. Oh, hey look, these are gone. It's just sine to the fourth. And that's as simplified as we can get it. Nothing else we can do with that. And as you can see, there are relations. Later we might deal with squareds, but right now, Pythagorean identities where it's going to be for the squares. Okay, so I know, yes, I know. Fractions are not friendly, but guess what? You can do it. I will give you a copy of this reference sheet. Don't lose it. Use it. I think I might have actually left something off here. I don't remember. If I did, you can add it down here or something. But for now, we're only dealing with the unit circle and not even for anything other than which quadrant we're in, and the fundamental identities right here. All right, guys, that's it for today. See ya.